All right, Unit 4.2. This will be our first video, and what this video does is it introduces the idea of a standard, of a rule, of a guideline that has to be in place in order for two functions to be inverses. So in order for two functions to be inverses of each other, they must be one-to-one. And what this really is that we're establishing a foundation for more advanced mathematics, but it's something that's in our standards, and so we must work through it and make sure you have this knowledge of what does one-to-one mean, and but for our purposes in this course, it'll just be an identification thing. It'll just be like, hey, is this one-to-one? And then most of the problems that you'll work will be one-to-one. You'll just have to work them through and then determine whether or not they're inverses of each other. So we're establishing today whether or not something is one-to-one, and then if it's one-to-one, if the two things are inverses of each other. So let's start off with the one-to-one piece. So the definition, two different inputs, so two different x's, correspond to two different outputs. So that's if something is one-to-one, that happens. So here's a visualization. On the first one here, we take a look at this. You've got x1, you plug it in, you get y1. You got x2, which is a different x, you plug it in, you get y2. What you notice here is that those are not the same y's. The y's cannot be equal to each other. So remember, this is y1 and this is y2. That's just in function notation. So then we move over here. So remember, this was one-to-one. We move over to the next one, and this one is not one-to-one. So with that said, let's apply the definition and see why. So we have two different x's, x1 and x2. You plug in x1. We don't know what we're plugging it into, but that's besides the point. We're just trying to get a visualization of the concept. You plug in x1, you get y1 out. You plug in x2, you get y1 out. So in this case here, what we just said is that we had x1 and x2 that are not the same, but when we plug them in, we find out that y1 is equal to, let me use function notation. We find out that f of x1 is equal to f of x2. And that can't happen. This right here has to be not equals, but that's not what we have. We have is equal. So this is not one-to-one. Therefore, whatever function we could have here would not be able to have an inverse. And then we have not a function. And so we've already covered not a function. With not a function, that's the one where you use the vertical line test. Okay, so we move on over to another example just real quickly. I'm not going to spend much time thinking about this, but obviously you can see this is one-to-one. So this is 1 to 1 because every x goes to one unique y. In this case here, this is not 1 to 1 because you have two different x's going to 1. You've got 1, 2, 3 different x's going to 1. So that's not one-to-one. Another example here, you got two different x's going to 1. So this is not 1 to 1. You can take a look at, someone gave you a set of ordered pairs. You can we've talked about making mappings, and this being a mapping right here. Remember, this is called a mapping. So, the thing is here is that some of you, or not us, some of you will be able to just look at this and say, like, oh, well, every x goes to a different y. And you'll be like, oh, yeah, I can see that. Others of you will need to actually go ahead and make that. So you actually, want to create a mapping. So you say domain is -2, -1, 0, 1, and 2. So you'll make yourself a little mapping, 0, 1, and 2. And then you'll say range, and that'll be 6, 3, 2, 5, 8. So at this point, you can pretty much see that nothing matches up. Like there's no duplicates. And so, we start drawing across 1-to-1, 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 1-to-1. So with a mapping, we can see that. All right, so, just different ways of looking at something and being able to say, what is the definition of one-to-one? How can I tell? Now, I'm not going to lie to you. My favorite way to see one-to-one is with a visual test. So when we come to the next situation here, we see, oh, well, wow, look at this. We've got, graphs And we have a special test, and that special test is called the horizontal line test. So just like the vertical line test, the horizontal line test is a test that you draw the line horizontally. So if you have a graph, which you guys have graphing calculators, so that means you can pretty much graph any function that someone gives you. So you have a graph, you take and you draw a horizontal line, and let's change that. Let's make that a dotted line, just so you kind of think of it as being imaginary, okay? So I just want to think of this as being an imaginary line that's being drawn with our, thought process. So kind of like this red line right here. It's just a line that we're drawing in our head to say, hey, how many times does it pass through? So we draw the horizontal line through a spot. We say, whoa, wait a second, it passes through 1, 2 times. But by definition, it can pass through at most 1 time. At most 1 time. So this would not be 1-to-1. This function right here would not be 1-to-1. And I could draw it in other spots too. I could draw it down here. I could draw it right here. But the point is no matter where I draw this line, it passes through more than 1 time. So this graph or this function is not 1-to-1. And you can see here we do the same thing with the next one. We can draw it right here. It looks like it's 1-to-1 because it passes through once. But remember, you have to think about it in every possible location. So, the easiest way to prove something is to prove something wrong. So when you're doing this, look for the spot that's going to prove it not 1-to-1. So here's the spot, 1, 2, 3. So this is not 1-to-1. Okay? So I'm going to put something in my calculator. Let's go to the next slide and see. Yeah, something happened to one of my slides. Let's scroll back through. I must have deleted it. That's typical Josh right there. So let me grab an equation and plug it in to my graphing calculator and look at it. So I believe you're going to have something like this in your homework. So like if I had an equation like 3x minus 1 and I hit graph. So the question is that 1-to-1? And and so I'll pull it off here on the side and just grab my little thing. Well, if I draw a horizontal line right there, that goes through 1 time. If I draw a horizontal line through right there, that goes through 1 time. So that is definitely 1-to-1. So let's put another one in there. Let's go. It's clear. Let's just do x squared minus 5. Okay. So what I want to do 2 things here is I want to try to help you understand, first of all, why the horizontal line test helps us, but I also want to just get that visualization again to get you to see, okay, so here's my graph, I draw my horizontal line, it passes through twice. So this is not a function. Well, the reason it's not a function is if I go to my table and look at this, if I chose -2, so for example, if I did -2, that ordered pair right there is -2, -1. If I go to +2, that point right there is +2, -1. So what I have here is I have an x1 and an x2. My x1 is not equal to my x2. However, when I plug them in, when I do f of -2, it equals f of +2. And that's the no-no. That's the thing that can't happen. They can't be equal. So that's why the horizontal line test happens, is because we have a y value that's being repeated. So this same thing like right here, that same y value is being repeated in 2 different spots. So 1, 2, 3, 4, 5. This ordered pair right here is something comma 5 and something comma 5. So the y value is repeated, and that's why it's not 1-to-1. All right, I think I beat that one to death. Good luck with that on the homework, and we'll move on from here.